Hello everyone, welcome to Sonnet Institute of Technology. My name is Bruce Malaudzi and I'm super excited to be your instructor today. Today we're talking about DHCP and this topic is mainly targeted to associate network engineers who are preparing for their CCNA routing and switching or the Computer N+. DHCP has been around for decades and DHCP stands for Dynamic Host Configuration Protocol. Basically, this is the server client architect of dynamically assigning layer 3 addresses to clients. Just to state a few facts here, DHCP uses UDP on layer 4, that will be the transport layer, and the ports being used, DHCP client will use port 68, while DHCP server will use port 67. And the DHCP process is pretty simple and can be summarized as DORA. In the first step, the client will send discovery packets, that will be the broadcast message to all the devices within the broadcast domain, that is all Fs. All the devices will receive that broadcast message, will encapsulate it. If they don't belong to them, they'll just discard. And if it belongs to a DHCP server, the DHCP server will then respond with an offer, that is step 2. Once the DHCP server responds with an offer, the client then requests for an available IP, that is step 3. Then the server will respond with an IP and acknowledge that the IP, you receive it, you're happy with that, and then the session will be closed. So all this can be summarized as DORA. D for discovery, O for offer, R for request, and A for acknowledge. Most small office, house office routers, SOHO routers, and Wi-Fi wireless access points are configured as DHCP servers by default. IPs issued by DHCP server normally expire after a certain period. Then the DHCP client will have to request again, going through the DORA process once again. DHCP server can be configured to reserve certain IPs in a defined pool. And you might be asking me, Bruce, why do we have to reserve certain IPs in a pool? In a network environment, you might have devices that need static IPs. Such devices could be a network printer, could be a Samba server, could be a network file system server, could be a web server, could be a DNS server. It could be any kind of server that needs static IP. It could be a switch for that matter as well. So if you need static IP, you got to reserve that IP, those IPs, so that when clients request for IPs, the DHCP server doesn't have to issue those IPs. They are reserved for special devices. And those IPs which are reserved, they can only be configured on the client manually. And next point is, if there is a conflict in IP detected during the DHCP process, that IP is removed from the pool and until the administrator has to resolve the issue manually. So that IP will be removed from the pool and will never be used again unless the administrator resolves the issue manually. And finally, reserved IPs are never issued to DHCP clients dynamically. In this lab exercise, the DHCP lab exercise, the minimum requirement or the minimum equipment you'll need one Cisco router, and I recommend using the iOS 15 and above. And then you will need one layer 2 switch, which you won't require a switch if you are using only one PC. And finally, you need one PC or more. In this demonstration, I will configure a Cisco iOS 15 router as a DHCP server. And please note that the the IP DHCP command is the only command in the iOS environment that accepts dotted subnet or the CIDR subnet notation. By dotted, I mean a subnet like .255.255.255.0, which can be represented in a CIDR notation as /24. The steps we will take basically in the first step, we will configure router 1. We will assign an IP address of 192.168.15.1/24 to the interface Ethernet 0/0. After assigning the interface an IP, we'll bring it up by using the no shutdown command, and then we'll define a DHCP pool using the IP DHCP pool command, and we'll name the pool as CCNA. Case sensitivity is not important, but using uppercase is it's a recommendation. After defining the DHCP, after naming the DHCP pool as CCNA, and then we'll define the network and then assign the default route and the default DNS. So this .8.8.8 is Google public DNS. Once we're done, we'll exit from the DHCP configuration mode. We'll exit to global configuration mode, and then we'll have to exclude these IPs. So exclude the .1 range from the .1, which is the interface IP. This IP is the interface IP of Ethernet 0/0. So we'll exclude it up to .20. So these are the reserved IPs which we are trying to reserve for our static devices such as printers, network servers, or switches, management stations, or firewalls, things like that. They need static IPs, so we are excluding from .1 up to .20. Finally, we will verify our configurations, and then we test for general connectivity. So here I am on GNS3 topology. I have my Cisco switch right here, and then I have my Cisco router, that is R1. Then I have 3 PCs that will be actually request IPs using DHCP. So this IP is actually representing the Ethernet 0/0. So the IP will be 192.168.15.1. So at this moment, the topology is ready for us. We just have to start the devices. At the moment, all the devices are off, so I just have to start them up. So by clicking here, so the devices are up and running and noted by the green dots here. So all I need to do now is to go into the Cisco switch, make sure that these interfaces which the switch is connected to, I need to make sure that the interfaces are all up and all interfaces belong to the same VLAN, so that we don't have issues in connectivity. So I just have to go into the switch. So here's the switch waiting for me. Thereby I will do the command show IP interface brief. So these are the interfaces within this switch, and all interfaces are up and running as noted here. Up. That means the interface is up on layer 1 and it's up on layer 2. So in this case, I'm good to go, and I've only got one VLAN here. So I can exit from here. Before I start configuring, I need to go to the PC, all 3 PCs, so I'll start one by one. The first PC, if I do show IP, This PC has no IP, as you can see here. IP and mask, nothing. Gateway, nothing. And please ignore this. We're not focusing on that. Our main focus is on this. Okay, so this PC has no IP and there's no gateway. So let me exit. Second PC, show IP, same applies. There's no IP, there's no gateway, there's no DNS, there's no whatever. So exit here. Third PC, show IP. Also there's no IP, there's no gateway, there's no DNS. So I can exit. All three PCs have no IP. So I need to start configuring. Thereby I'll go into the Cisco router and I will have to get into global configuration mode. That will be conft in short. And I need to switch on to Ethernet 0/0. Then I need to assign an IP address of 192.168.15.1/24. That will be 255.255.0. Then I have to bring the interface up by doing the no shutdown command. That will be no shut. And I can double check the configuration by doing show IP, do show IP interface brief. So I'm interested in Ethernet 0/0. My IP address is right here and it's up on layer 1, up on layer 2. The rest of interfaces are down, of which we're not interested in them. So I'm good to go. Now I can exit to get back to global configuration mode. I was in interface configuration mode. Now I'm back in global configuration mode. So I need to define my DHCP pool. That will be IP DHCP keyword pool. Then I can name my DHCP pool as CCNA. Remember, case sensitivity is not important, but it's recommended to use uppercase for easy troubleshooting. So it's IP DHCP pool CCNA. Press enter. As you can see, I am now in DHCP configuration mode. Now I need to define my network. That will be the keyword network. My network is 192.168.15.0/24. Now I need to define my default router. That will be 192.168.15.1. And my DNS server will be 8.8.8.8. At this moment I need to exit and go back to global configuration mode. Now I need to specify the reserved IP addresses. Remember, we're supposed to reserve from .1 to .20 according to our requirement. Therefore, the command is IP DHCP excluded address. So the first address is the address to the router itself, the default gateway. That will be 192.168.15.1 up to 192.168.15.20. And at the moment I'm good to go. So I can end, and if I want to write these configurations, I can do write to memory. That will be WR. Press enter. So my configurations are written to memory. So if I do show IP DHCP pool, my pool is named CCNA, and I've got 254 addresses available. At the moment, there is no one there's no client that has requested for an IP. So the list addresses is 0. So what you can do now, I can exit from here and let's get to the PCs. So here I am on my first PC. I just have to double check and see if, so I still have no IP here, right? And let me request one. That will be IP DHCP. So the DORA process will take place, as you can see here, ORA. So DORA process has successfully completed, and I've got an IP now. So the IP that has been assigned to this machine is .21. So now if I do show IP, I can see the more details about the network configurations. So the IPv4 address assigned is a .21. The default gateway is a .1. The DNS server is 8.8.8.8, and the DHCP server is right there. I also have the lease value that will be in seconds, sometimes in minutes, whatever the case is, but you get all the information in. So I can exit from there and get to the second PC. The second PC, I can do show IP. Okay, there is no IP assigned, so let's request for one. That will be IP DHCP. So the DORA process will go through again, and there you go, the process is finished. We got an IP. So if I do show IP, I have IP assigned as .22, and the rest of the information is right here. So let me exit from here, and finally to the third PC. Third PC, show IP. There's no IP assigned, so let's request for one. So that will be IP DHCP, and it will go through the DORA process. IP was successfully assigned. It was .23 was assigned to this host machine. So if I do show IP, here we go, it's a .23, and we got the default gateway, the DNS, and the DHCP server information. So now we need to test for general connectivity. So if I ping the default gateway itself, that will be ping .168.15.1. I do have a ping reply. So if I ping the other PCs or the neighboring PCs, so that will be ping, let's choose any one of the PCs, that will be 198.168.15.21, for example. So I have a ping reply as well. So let's get to the exit from here. Let's go to the Cisco router. Here I am on the Cisco router. If I do the command show IP DHCP pool, if you go under list addresses, we have this router has listed 3 IP addresses to the client. So which is true. We have 3 PCs and they all have IP addresses. So we can check for general connectivity as well from the Cisco router itself. So that will be ping 192.168.15. So the first PC is 21. So we have ping replies, so all is working. The second PC was assigned a .22. So the pings are successful. The third PC was assigned a .23. The ping are successful. So I can exit from here. So everything is working. And in summary, to summarize this, I did walk through the DHCP protocol itself. I did explain to you briefly what happens behind the scenes in DHCP. The layer 4 protocol that DHCP uses, it uses UDP, and ports 68 and 67 are involved. And then and then specify that port 68 is used by the DHCP client, while port 67 is used by the DHCP server. And then explain to you that the DHCP process, it can be simplified as DORA, D for discovery, O for offer, R for request, and A for acknowledge. And then walked you through on GNS3 topology, whereby we have 3 PCs acting as DHCP clients and a Cisco router that will be configured as a DHCP server. We then assigned an IP to the Ethernet 00, an IP of 192.168.15.1. After that, we brought the interface up. We then defined a DHCP pool. We named that pool as CCNA. We then excluded our reservations from .1 to .20, and then we went back to the 3 client PCs, which is the DHCP clients. We then started requesting for IPs. The first client which requested for IP received an IP of .21. The second PC which requested received a .22. The third one received a .23. If there was a fourth one, it was going to receive an IP of a .24. I hope this has been informative, and I would like to thank you for watching. I'll be seeing you in the next video. Goodbye for now.